Hey guys, Mr. Middleton here. Today we're going to talk about order of operations. At the end of this video, you should be able to use the order of operations to simplify expressions, and you should be able to evaluate expressions using the order of operations. Alright, so the mathematical order of operations is used to simplify expressions correctly. Okay, an expression is a mathematical phrase, okay, which means that it does not have an equal sign. Okay, an acronym often used to help us remember the order of operations is PEMDAS. Please excuse my dear Aunt Sally. Okay, and so P stands for parentheses, E stands for exponents, C's exponents, multiplication for M, multiplication, division for D, addition, and subtraction. Okay, you'll notice that I have boxes around multiplication and division and addition and subtraction, and that is because these operations are done as they appear from left to right. Okay. The reason that these are done this way is because addition and subtraction are essentially the same thing, or can be written as the same thing. If I said 3 minus 2, I could do that same thing. It's equivalent to me saying 3 plus negative 2. So notice that addition and subtraction are the same thing. Same with multiplication. If I said 5 times 1/2, that's the same as me saying 5 divided by 2. So again, addition, multiplication, and division are the same thing, or essentially the same thing. Okay? So if you look at this expression here, we have 8 divided by 2 times 4. We need to simplify this. Notice there are a bunch of different ways we can do it. If you do the multiplication first, 2 times 4 would give us 8. 8 divided by 8, you get 1. However, if you do the division first, we'd say, okay, 8 divided by 2 is 4. 4 times 4 is 16. You get 16. So the order definitely matters, because if it didn't, we'd get the same answer no matter what. So here, the correct answer is 16, because you work left to right. Multiplication and division, you do it at the same level. Go left to right, do division first in this case. Alright, so we got some practice problems down here. Let's work together on solving these. Number 1, we had 32 plus 6 squared minus 14 plus 3. We'll go through our order of operations to simplify this correctly. First thing our order of operations would tell us to do was parentheses. 14 plus 3, 17. The next thing it would tell us to do, and I'll just write this step so we have them all. The next thing it would tell us to do is the exponent. So this exponent, we have 6 squared, gives us 36. And then from here, addition and subtraction, we just do it from left to right. 32 plus 36 gives us 68. 68 minus 17 gives us 51. Okay. Alright, number 2, we have 15 divided by 2/5 plus 1/4 times 8. Okay, notice there are no parentheses here. We have multiplication and division, so we'll do division first here. 15 divided by 2/2. Remember, 2/5. Remember, when we divide by a fraction, what that means is that we're going to multiply by its reciprocal. And so that'll give us 50/75 over 2 here. Okay, and then we have addition, and then 1/4 times 8. So we'll do multiplication first. We'll do multiplication before addition. And so we'll do the 1/4 times 8. And that will give us 8 over 4, or 2. So we have 75 over 2 plus 2. In order to add these together, we need to have the same denominator. And so in order to get that, I am going to multiply this by 2 over 2. That way we get the denominator to be 2. And so we'd have 75 over 2 plus 4 over 2, which gives us 79 over 2. Okay, and I can leave that answer like that. Okay, if there are directions that tell you to round to the nearest tenth, or leave it as an improper fraction, make sure you follow those directions. Alright, number 3, we have 12 minus 4 plus 3. This is a problem where we work from left to right. Okay, so from left to right, 12 minus 4 gives us 8. 8 plus 3 is 11. Alright, 4 is challenging. I'd like you to try that on your own. Okay, and bring that in completed tomorrow. We'll talk about it. Alright. So evaluating expressions. When we evaluate an expression, we are replacing a variable with a number. Okay, or an unknown with a known. It is a good habit to use parentheses whenever you do this. Okay, that way, when you plug it in, you're able to simplify correctly. So the first problem asks us to evaluate the expression when x is 5 and y is negative 2. And so what we'll do is we'll plug in. Evaluate just means substitute the known for the unknown. Substitute a number for a variable. And then we'll simplify still using order of operations. We will multiply first. 3 times 5 is 15. 2 times negative 2 is negative 4. Plus negative 4. So when we have to add a negative, that means we're subtracting. So 15 minus 4 will give us 11. Second problem, doing the same thing, plugging in 5 minus 2 times negative 2, 5 minus negative 4, minus a negative. We're minusing a negative, that means we're adding. So 5 plus 4 is 9. Anytime you see two operation signs next to each other, you need to say, what are they asking me to do? Okay. Clear it up with yourself so you know there's only one operation happening. Okay. Try number 3 and bring that in completed for me. Number 4. Here's where it's really important to be plugging it in with using parentheses. Okay, especially if you're using your calculator. Your calculator, if you just put negative 2 squared, will tell you the answer is negative 4. If you put it in parentheses, even your calculator will know, oh, this is negative 2 times negative 2 because it's squaring it. And so that answer will be 4 divided by, because we'll want to do these parentheses now, 13 minus 5, which is going to be 8. So 4 divided by 8, which is 1/2. Okay? Or I should say 4/8, and then it's 1/2 simplified. So this will be our final answer. So let's look at evaluating and see if we can check John's claim. John claims that x plus y squared equals x squared plus y squared. Let's show if John's correct. So what John said was x plus y squared, and what we're going to check by evaluating with these values. We're going to say, okay, well, x is 5, y is negative 2. Do it like that. Okay, 5 plus negative 2, that's 5 minus 2, because plus a negative is just minus 5. Minus 2 gives us 3. And so we'll have 3 squared, and that is 9. Okay? Now John said x squared plus y squared is the same thing, so let's check. So we have 5, because that's what x is, squared, plus negative 2 squared. And that will give us 25 plus 4, which gives us 29. And so we see that those two things are not equal. So x plus y squared is not the same as x squared plus y squared. So is John correct? The answer is no, he's not. Okay, this example shows evaluating expressions can be used to check your other work. Okay, so especially as we go through solving, it'll be important and a good idea for you to go back, plug, or evaluate your answer and see if it makes sense. Okay, a symbol you should know is the absolute value bars. They represent a certain number's distance from 0. Okay, important to remember that distance cannot be negative. Whether I go 5 miles east or 5 miles west, I go 5 miles. So distance is always positive. Okay, so this first question asks us how far is negative 4 from 0? We can go from 0, 1, 2, 3, 4. It is 4 units away. So we represent that by saying that the absolute value of negative 4 is 4. The distance negative 4 is from 0 is 4. Okay, how far away from 0 is 3? Or how far away is 3 from 0? Well, it's 1, 2, 3. Really don't need to count it, but we will. Okay, and we can represent that, kind of mirroring this previous example here, by saying the absolute value of 3 is 3. So again, notice it is not the opposite of the number inside the absolute value bar. It is just the distance, which has to be positive. Okay, those are your notes for order of operations with evaluating expressions. Okay, make sure you do the couple examples, and I'll see you